a PhD thesis from the Karolinska Institute, no less. We're going to break down how you can supercharge your body's energy systems. But here's the thing. The results are probably not what you're expecting.
I mean, seriously, what if I told you that just 4 minutes of all-out exercise could pack the same punch as a whole hour of hard training? Sounds like a fantasy, right? Like a workout that's done before your coffee is even ready? Well, hang on, because the science we're going to get into today, it suggests this isn't science fiction at all.
So to really wrap our heads around this, we need to go microscopic. We're going to zoom way in, deep inside our own muscles, to these tiny little engines that are the secret to, well, everything, from just feeling good every day to hitting your peak performance.
And here they are, the mitochondria. You've probably heard them called the powerhouses or power plants of the cell, and that's exactly what they are. Their whole job is to take the fuel you eat, fats, carbs, and turn it into actual usable energy called ATP. That's what makes your muscles move. It's a pretty simple equation, really. The more of these power plants you have, the more power and endurance you've got. End of story.
Okay, now this is where it gets really cool, because this slide just blows up the old textbook image we all have in our heads. We're taught to think of mitochondria as these little lonely beans floating around, but nope, that's not it at all. The reality is, it's a huge, sprawling, interconnected network. It's less like a handful of batteries and more like a city's entire power grid, woven all through your muscle. And here's the best part. You can actually build more of this power grid. The science is clear on this. A well-trained athlete can have literally double the mitochondrial content of a sedentary person. That's a huge difference. And that's the secret sauce for endurance. So, the big question is, how do we tell our body to start building?
Well, it turns out scientists have found the command for start building. They've identified a very specific signal inside our cells. Think of it like the master switch for the whole construction project.
And that master switch has a name, PGC1 alpha. When we exercise, we put our body under a bit of stress, right? And that stress is what literally flips this switch to on. Once it's on, PGC1 alpha kicks off this whole domino effect, ordering the body to build more power plants. So when researchers measure this gene, they're basically eavesdropping on the cell's internal memos. And check this out. This shows you exactly how it works. When you exercise, all this stuff happens inside your muscles. Calcium levels go up, energy molecules shift around. Don't worry about the specific names. The point is, all these signals come together like rivers flowing into a sea, and they have one job, to scream at that PGC1 alpha switch and flip it on. It's a perfect chain reaction. Okay, so the researchers knew about this master switch. The next logical step was to figure out, all right, which workouts flip this switch the best? And this is where things get really interesting. So in one of the key studies, they took a bunch of elite cyclists, we're talking top-tier athletes, and put them through 2 totally different workouts. In one corner, you have your classic, long, high-volume interval session. And in the other corner, a super short, absolutely all-out sprint workout. And just look at these numbers. It's insane. The one workout was a full hour of hard work. The other one, just 3.5 minutes of actual pedaling. The total amount of work they did was almost 8 times more in the long session. I mean, common sense says the 60-minute workout should give you a way bigger signal to adapt, right?
Yeah, well, prepare to have your mind blown. This is the big reveal. Despite that huge difference in time and effort, the effect on that PGC1 alpha master switch was pretty much the same. Let that sink in. Less than 4 minutes of sprinting sent the exact same signal to build more power plants as a whole hour of grinding. What on earth is going on here?
And it just gets weirder. The researchers kept finding these strange clues. Like, for people who are untrained, a long, slow bike ride gave the same signal as a hard interval workout. And get this, adding heavy leg presses after a bike ride actually doubled the signal. It's like none of this makes sense on the surface.
So you've got sprints, long rides, and even lifting weights mixed in. These workouts couldn't be more different, but somehow they're all pushing the same big red adapt button. What's the one thing they all have in common?
Well, the answer, it turns out, has nothing to do with how long you go or even what you're doing. The real secret is all about what's in your fuel tank.
And here it is, straight from the source. The author realized that when they looked at all the data, there was one common thread. The biggest signal for building new mitochondria always happened when the muscle's main fuel source was getting seriously depleted.
And that fuel source is something called muscle glycogen. You can just think of it as carbs that are stored right there in your muscles ready to go. It's your body's favorite, top-shelf, high-octane fuel for when the going gets tough.
Okay, and this right here, this is the smoking gun. They designed a study to test this idea directly. They had cyclists do the exact same workout twice, once with a full tank of glycogen and once when they were already running low. The results were just staggering. The PGC1 alpha signal was almost 3 times higher when they trained on a low tank. That's not a small difference, that's a game changer.
So there it is. The secret ingredient is something called energetic stress. All those weirdly different workouts, the short sprints, adding in the leg presses, doing a ride on an empty stomach, they all do one thing really well. They burn through that muscle glycogen super fast. And when that fuel gauge gets low, it sends a little panic signal to the cell, basically saying, hey, we might be in trouble here. And the cell's response is to immediately hit that master switch to build a bigger, better power grid so it's more prepared next time.
So what does this all mean for us? Well, it brings us to a really powerful takeaway. It suggests that your fueling strategy, what you do before and after you train, could be just as important as the training itself.
Let's just recap the whole process. Step 1, you create a stimulus that burns through glycogen. That could be those crazy short sprints, or it could just be doing a normal workout when you're not fully carbed up. Step 2, that low fuel state creates the energetic stress we've been talking about. And step 3, your body responds to that stress by flipping the master switch and saying, okay, time to build more power plants so this doesn't feel so hard next time. It's a beautiful system.
You know, this research really flips the old advice. The idea that you have to carb load before every single workout completely on its head. Now, don't get me wrong, for a big race or a peak performance, you absolutely want a full tank. But for just driving adaptation, for telling your body to get better, this suggests that strategically training in a low fuel state could be one of the most powerful tools you have. It really makes you wonder, doesn't it? Maybe it's time we all rethink how we fuel our workouts.